Hello, welcome back to Statistics and Mathematics YouTube channel. Today we are going to start our studies on calculating the working on hypothesis testing for the population proportion. So for hypothesis testing for population proportion, we do this test by using what? Z-test, right? The one that we use for hypothesis testing for the population mean when our standard deviation is known. That is the test that we are going to use, right? So for us to be able to use that test, we are going to use what we call the Z calculated. We are going to use what we call the Z calculated, and then Z subscript alpha and Z subscript alpha divided by 2 to make our conclusion, since it's an hypothesis testing. So the Z calculated is represented by this one. So Z calculated is equal to P hat minus P divided by square root of P times Q divided by N. Right? So this is what our P calculated. So let's really explain the parameters for us to really understand what is going on here, right? So for here, our P hat is a sample proportion, right? This is our P hat. That's a sample proportion, and our sample proportion is equal to X divided by N. That's our sample proportion. And then the P, the P that we see here is the population proportion. Our N is also represented by our sample size. So that is the explanation for the parameters that we have. And then this is how we can also set our hypothesis too. Because I taught you guys how to set your hypothesis. So let me briefly do that one here before we jump into solving questions. So once you have been able to know our Z calculated, and I told you guys that we are going to just compare the Z calculated to our Z critical. When it is a one-tailed test, we are going to use Z subscript alpha. But when it is a two-tailed test, we are going to use what we call Z subscript alpha divided by 2. Right? So let's set the hypothesis here for you to really appreciate what we are doing here. So here, when it is one-tailed test and it's tailed to the right, we are going to have H naught said that our P will be equal to a certain, let's say, M. That's a certain value, M. And then our H1 will be P, will be what? Greater than a certain M at an alpha of 0.05. Right? And then for a left-tailed test, we are going to have a hypothesis of our H0, P is equal to M, H1, P is less than M. And then for a two-tailed test, we are going to have H0, our P is equal to M, H1, our P is not equal to M. So this is what basically we are going to have for a one-tailed test. So for a one-tailed test, this is what basically we are going to have for our hypothesis. So let's kindly know how to set the hypothesis so that when we start solving questions, things will not become dicey for you. Okay? Yeah. So question 1. Let's read it and solve it. Said a dietitian claims that 60% of people are trying to avoid trans fat in their diet. She randomly selected 200 people and found that 128 people stated that they were trying to avoid trans fat in their diet at an alpha which is equal to 0.05. Is there enough evidence to reject the dietitian's claim? So you see that a random sample is selected here. So it means that this 60% that you can see here will be what? Our population. Let's kindly write our parameters down before we start solving the question. So it means that this 60% that we have here will be the population proportion. So we'll be having 60% here, which can also be written as 0.6. Right? It can also be written as 0.6, right? And then we have our sample size to be 200. And then we have our X to be what? 128. Our alpha 2 is given as 0.05. So we have been asked. So once you have these parameters down, this one will just tell you clearly that you are going to use the Z test for the proportion, right? But before that, we have to we know that our Z is equal to P hat minus P divided by p hat minus p divided by sigma square root of n, right? Sigma, sorry, sorry, I have done a mistake here. It's not sigma, it's rather, I'm sorry, it's not sigma, but it's rather square root of pq divided by n. So that is the square root of pq divided by n. So so right now we have to get our p hat before we can continue, right? We know that our p hat is given by x divided by n, and our x is given as 128, and our n is given as 200. So once we divide this one, we are going to get our p hat to be what, 0.64. So that will be our p hat. Right now we have our p, so when you subtract it from 1, we are going to get 0.4. Right, so right now we have our parameters. That before we start with this thing, we have to set our hypothesis, right? And our hypothesis is at what? The first paragraph. This is where our hypothesis will lie, right? So we said a dietitians claim that 60%. So here the 60%, you are just seeing here that here the test will be a two-tailed test. So here our population proportion is given to us. So H not to be population proportion is equal to 0.6, and then population proportion is not equal to 0.6 at an alpha level of 0.05, right? So right now we have our parameters, we have set our hypothesis. Then let's jump into the calculation, right? So here we have our z. Our z is equal to p hat minus p divided by square root of p times q divided by n. So you are just going to substitute what we have here inside this whole expression. When you substitute and you do your subtraction, your division and square root, where we are going to get our z calculated to be 1.15, and then this 2 is what? A one-tailed test. And for a one-tailed test, this is a two-tailed test, so we are going to have our z subscript alpha divided by 2, which will be equal to z of 0.05 divided by 2 to be 0.025, of which you have done similar example on this one. And if you go to the z distribution table, you are going to get 1.96. So please, if you haven't watched the videos on normal distribution, kindly go and watch, because it will be of your own benefit to know how to calculate for the z test, okay? Sorry, the z critical. So you are going to have plus or minus 1.96, and then you can see that our z is lying at the positive section. So for this critical value, we are going to use the positive one. We are not going to use the negative one, right? So when we come here, we have shown it on a nice diagram here for you to really understand. So this will be our critical value at the positive side, that is positive 1.96, and at the negative side, negative 1.96, right? And then you can see clearly that our z calculated lies in the fail to reject region. That's 1.15. So you can see clearly here that since our z critical, right, z critical is greater than our z calculated, we are failing to reject H naught, and hence there's the claim that 60% of people trying to avoid 60% of people are trying to avoid their trans fat in their diet. So that is the solution for this question. So please kindly take your time, watch the video well, and everything will be fine. Let's jump to the next question. So for question 2, it said a statisticians read that at least 70% of the population oppose replacing $1 bills with $1 coins. To see if this claim is valid, the statisticians selected a sample of 80 people and found that 55 were opposed to replacing the $1 bills. At an alpha of 0.01, test the claim that at least 77% of the population opposed to what they change. So this is the question given to us, and then we have been asked to solve this question. And then you could see that our population proportion is given to us as 77%, which can be written as 0.77. right? So if you want our Q, you will get it to be 1 minus P, which is 0.23. So that is our Q. Our Q is what? 0.23. That's for our Q. And then you can see from the example is selected, and then our N was given to us at 80, and then our X was given to us at what? 55. So if you want our P hat, it will be X divided by 55. That's 55 divided by what? 80. And when you do it nicely, you are going to get 0.6875. Right? So we have gotten our parameters down. Once you have our parameters down, then let's set our hypothesis. So you could see clearly here that this is what? A left tail test. Right? This is what? A left tail test. Says a statistician read that at least 77% of the opposed replacing $1 bill within $1 coins, right? So this is a left tail test, right? This is a left tail test. So you see that for this one, we are seeing at least here, right? At least here means that our H naught will be what? Greater than or equal to 77%. Right? So if our H naught is greater or equal to, the opposite of the greater than will be less than. That's what? Our H1 will be what? Less than. That's our H1. So here we are going to have H1, our H1 to be what? Less than. So this one will be what? Tilt to the left. And I told you in my previous videos that it's not strictly that always we are going to use, in most literature, we are not, you don't usually see the greater than or equal to. You must see what? Equal to. That's the reason why I didn't bring the greater than or equal to here, right? So here, this is how the hypothesis will be at an alpha of 0.01, right? So let's jump into the main calculations. So here our Z is given to us in this form, right? So we have them here, the parameter, just substitute it, and if you're able to do your addition, subtraction, and multiplication very well, you are going to have negative 1.75. And then this is what? A one tail test. So we have a negative Z subscript alpha, which will be negative Z subscript 0.01. And if you go to the Z table and then calculate for that, we are going to get negative 2.33. Right? So set the hypothesis, and then you can see clearly that the Z calculated lies in the fail to reject region, since our Z critical is less than our Z calculated. It's false in the fail to reject region, and hence we are not going to reject the claim, right? Yes, we are going to fail to reject the claim. So this is some examples and theorems that I can teach you guys on Z-test for Z-test for population proportion for hypothesis testing. So I'll leave the last question with you. So kindly solve the last question and share your answer at the comment section below, and I'll come and reply you if you are right or wrong. Thank you for watching. Bye. This is Statistics and Mathematics YouTube channel.